Hello, my name is Danny Fox. I work in the microscopy research group with Dr. Hongzhou Zhang. So nanotechnology. We study the fascinating properties the materials exhibit when isolated at the nanoscale. So if you were to compare the size of the Earth to the size of a marble, it would be equivalent to comparing the size of a tennis ball to an atom. And in nanotechnology, that's really what we're dealing with, just rows of atoms. And when isolated at this scale, materials do not necessarily behave as their bulk counterparts would suggest. Take, for example, this graphite pencil. We're all familiar with its properties. It can be used to write. It can be easily broken. But when isolated, when graphite when atomically thin layers of graphite are isolated, they are the strongest material ever measured, and they conduct electricity and heat better than any other material. But it's a real challenge to work at this scale, and we need to be able to see what we're doing. So we use high-powered electron microscopes to analyze the structure and the composition of nanomaterials. And in these microscopes, we use very strong electric fields to accelerate electrons into materials. And then we can observe what happens by looking at, for example, the deviation of the electron from its original path after passing through the material, or the amount of particles knocked out of the material by the electron, or simply how many electrons that we fire at the material just bounce straight back. These are just some of the types of information that can be used to see the sample and form an image. And our research interest is not only in observing nanomaterials, but also in modifying their structure and their properties at the nanoscale. So instead of accelerating electrons at the material, we can accelerate ions, which are much heavier. And we use ions with a mass of up to 130,000 times that of an electron. And these ions cause a change in the local structure of the material upon impact. And the huge resolving power of these microscopes means that we can confine this modification to regions of just a few nanometers. And then we use the electron microscopes to analyze the extent of the modification. So what can this be used to do? Well, materials which are modified at the nanoscale, their physical properties can be controlled. And we can, for example, tailor the optical properties for photonic devices. And photonic devices are optical devices which are significantly faster and more efficient than their electronic counterparts. And similarly, we can change the electrical, the mechanical, and even the magnetic properties of materials just by manipulating them at the nanoscale. And it's when we apply this fundamental level of physical control to already exciting nanomaterials such as graphene that we open up a whole world of possibilities for revolutionary new devices and applications. Thank you.